What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into Amazon Kinesis, real-time versus near real-time streaming. Let's get into it. By the end of this video, you'll know exactly when to pick Kinesis data streams versus Firehose. And this single distinction is one of the most heavily tested decisions on the Amazon Web Services Certified Data Engineer Associate exam. Get it wrong and you'll fall for trap answers across the entire streaming domain. Get it right and you can eliminate 2 or 3 wrong choices on almost every streaming question. We're going deep: shards, enhanced fan-out, format conversion, the IteratorAge trap, and the one rule that wins exam questions. Here's the question that decides every streaming answer on this exam. Real-time or near real-time? That's it. That's the whole framework. Because the moment you correctly classify what the scenario is asking for, half the answer choices fall away as obviously wrong. Millisecond latency means one service. Buffered delivery to S3 means a completely different service. And mixing them up is exactly what the exam writers are hoping you'll do. Think of it like this. Kinesis data streams is a phone call. You hear the words the instant they're spoken, with latency measured in tens to hundreds of milliseconds. But you manage the line, you provision shards, you write the consumer code, you handle scaling. Your tools are the KCL, Lambda, or managed service for Apache Flink. And you can keep records around from 24 hours all the way up to 365 days for replay. Firehose is the postal service. Your letters get bundled at the post office for somewhere between 60 and 900 seconds before delivery. It's fully managed, no shards to size, no consumer code to write. It delivers straight to S3, Redshift, OpenSearch, or Splunk, but there's no retention concept at all. Firehose is pure pass-through. Let's open up data streams and see what's inside. On the left, your producers, typically using the Kinesis producer library, push records into the stream. In the middle, the stream itself is divided into shards. Each shard is a highway lane that handles 1 megabyte per second of writes or 1,000 records per second, whichever you hit first. On the read side, each shard delivers 2 megabytes per second, shared across all classic consumers. And on the right, those consumers can be a KCL application, a Lambda function, or a Flink job running on managed service for Apache Flink. Here's the part the exam loves. If your writes exceed 1 megabyte per second per shard, you get a provisioned throughput exceeded exception. The fix is to add more lanes, more shards. This is the manual scaling responsibility that comes with real-time streaming, and it's the price you pay for millisecond latency. Straight from the Amazon Web Services Developer Guide. By default, a data stream holds records for 24 hours. You can extend that all the way up to 365 days, that's 8760 hours, using the increased stream retention period operation. This is the replay superpower. If a downstream consumer crashes for a week, you can rewind and reprocess. If a machine learning team wants to backtest an algorithm against last quarter's events, the data is still there. Firehose has no equivalent, it's pure pass-through. So when the exam says replay events from 30 days ago, that's pointing straight at data streams with extended retention. Burn this into your memory. If the question mentions real-time, millisecond, or sub-second latency, the answer is Kinesis data streams. Full stop. If the question mentions delivering to S3 with the least operational overhead, the answer is Kinesis data Firehose. These 2 trigger phrases decode the majority of streaming questions on the exam. They are not interchangeable. They are not similar services with different pricing. They solve fundamentally different problems, and the test writers know which one you'll be tempted to pick incorrectly. Let's go tier by tier. Data streams with enhanced fan-out delivers in roughly 70 milliseconds. Data streams with classic polling sits around 200 milliseconds. Firehose 0 buffering 2023 lands at roughly 5 seconds. Standard Firehose buffers for 60 seconds. And Firehose maximum buffer caps at 900 seconds, a full 15 minutes. Notice the jump. Going from data streams to Firehose is not a small latency trade-off. It's orders of magnitude. That's why the moment a scenario demands real-time response, Firehose is automatically wrong. Read this carefully because every word matters. 2 megabytes per second per shard, dedicated per consumer. In classic Kinesis, all your consumers share that 2 megabytes. Add a 5th consumer and everyone slows down. With enhanced fanout, each registered consumer gets its own private 2 megabytes per shard, and the data is pushed to them over HTTP2 instead of being pulled. And this feature, critically, is data streams only. Firehose has no fanout concept whatsoever. Here's the picture. Classic Kinesis is a shared buffet line. Every consumer walks up to the same shard and pulls records by polling, and they're all eating from the same 2 megabytes per second plate. Add more consumers and contention grows. Latency hovers around 200 milliseconds. Enhanced fanout gives each consumer their own private waiter. Each registered consumer gets a dedicated 2 megabytes per second per shard, pushed straight to them over HTTP2 using subscribe to shard. Latency drops to about 70 milliseconds. You can register up to 20 consumers per stream by default, with the ability to request a service quota increase through Amazon Web Services support. And remember why this can never exist on Firehose? Firehose hides shards from you entirely. There's no shard-level subscription API to attach a dedicated consumer to, because Firehose isn't a stream you read from. It's a delivery service that pushes to destinations. So if you see Firehose plus enhanced fanout in an answer choice, that answer is wrong by construction. Now here's where Firehose really shines. Picture IteratorAge's clickstream. The marketing team is firing JSON events at the stream all day. Without format conversion, those land in S3 as raw JSON files, which are slow and expensive to query in Athena. With format conversion enabled, Firehose does 3 things on the fly. First, a deserializer, either OpenX or Hive, parses the incoming JSON. Second, it looks up the schema from the Glue data catalog so it knows the column types. Third, a serializer writes the records out as Parquet or ORC, the columnar formats Athena loves. The data lands in S3 already analytics ready. No Glue ETL job, no EMR cluster, no Spark code. 2 gotchas to remember. The buffer minimum jumps to 64 megabytes when format conversion is on. And if a record doesn't match the schema, Firehose writes it to an error prefix in S3, which can cause delivery stalls until you fix the schema drift. So schema discipline matters. Here's the pattern you'll see in real production systems and on the exam. Start with IteratorAge's clickstream producing events. Send them into a data stream that gives you millisecond latency and multiple consumers. From there, branch. 1 consumer is managed service for Apache Flink, doing real-time pattern detection and alerting sub-second response. The other consumer is a Firehose delivery stream, which buffers the records, converts them to Parquet, and lands them in S3 for Athena to query. This combo gives you the best of both worlds. Real-time fanout for the use cases that need it, and managed columnar delivery for the analytics that don't. The architecture honors the latency requirements of each downstream consumer instead of forcing one tool to serve both jobs. Pay attention to this one. In August 2023, Amazon Web Services renamed Kinesis Data Analytics to Amazon Managed Service for Apache Flink. Same service, same capabilities, only the name changed. Exam questions still use both names interchangeably, so translate freely between them. One critical date to know: Kinesis Data Analytics for SQL retires on January 27, 2026. That means legacy SQL apps must migrate to Flink Studio before that date, after which Amazon Web Services shuts them down and they stop functioning. So if a question mentions Kinesis Data Analytics, mentally map it to Managed Service for Apache Flink. So when do you reach for Managed Service for Apache Flink? First, anytime the scenario involves stateful processing, windowing over a rolling 5-minute interval, joining two streams together, or sessionizing user activity. Next, anytime you need exactly once semantics, because raw Kinesis only gives you at least once delivery. Then there's real-time pattern detection, fraud detection on credit card transactions, anomaly detection on sensor data, complex event processing where the meaning is in the sequence. Watch the date. Kinesis Data Analytics for SQL retires January 27, 2026, so legacy apps must migrate to Flink Studio before then. And finally, languages. You write your Flink application in Java, Python, Scala, or SQL through the Studio Zeppelin notebook environment. Next streaming option, Amazon MSK, which stands for Managed Streaming for Apache Kafka. The question is when you'd pick this over Kinesis. Default to Kinesis. For greenfield streaming on Amazon Web Services, Kinesis wins on operational overhead, integrates natively with Lambda, Firehose, and Flink, and gives you a clean per shard throughput knob. A large enterprise evaluating Confluent Kafka versus Kinesis for their event bus might choose Kinesis specifically to avoid Kafka operations. Pick MSK when the question forces your hand. You're migrating existing Kafka producers and consumers and rewriting them with the KPL and KCL isn't on the table. You need Kafka-specific features like compacted topics or transactions. Or you need topic-level access control with Kafka ACLS, which work when you're using TLS or SASL/SCRAM authentication. One subtle gotcha: if you configure MSK with IAM authentication instead, Kafka CLS are completely ignored. You have to use IAM policies in that case. Okay, now we get to the biggest trap in the whole streaming domain: IteratorAge. This Amazon Web Services Knowledge Center quote is the answer key. IteratorAge grows when your Lambda function can't process records as fast as producers are writing them. And the fix is to increase stream processing throughput. Read that last sentence again. The fix is throughput, not concurrency, and not memory allocation. Throughput on the red side of the stream. This single sentence eliminates the most popular trap answer on the exam. Here's the trap side by side with the fix. On the left, the wrong answers: increasing Lambda reserved concurrency, increasing the account's unreserved concurrency, switching to provisioned concurrency. None of these add red throughput on a per shard basis. The bottleneck isn't how many Lambda functions you can run, it's how fast records can be pulled out of each shard. On the right, the correct fixes. Add more shards so there's more parallel read capacity. Raise the parallelization factor from the default of 1 up to 10, which lets multiple Lambda invocations process a single shard at once. Register your consumer for enhanced fanout to get dedicated throughput. Make the Lambda code itself faster. Fix any batch errors that are forcing retries. The mental model Lambda concurrency is about how many cashiers you have. IteratorAge is about how fast records come off the shelf. More cashiers can't help if there's only one clerk handing them records. Here's the actual lever. When you create the Lambda event source mapping for a Kinesis stream, you set parallelization factor. Default is 1, maximum is 10. With parallelization factor at 10, a single shard can be processed by up to 10 concurrent Lambda invocations instead of 1. That's a potential 10 times speed up on IteratorAge. But there's a critical detail: Order is preserved per partition key, not globally. Records sharing the same partition key always go to the same Lambda invocation in order. Records with different partition keys can be processed in parallel. So if you partitioned by customer ID, all events for one customer stay ordered, but events for different customers process simultaneously. In one practitioner gotcha, parallelization factor of 10 only works if your account has enough unreserved concurrency. If your stream has 50 shards and you set the factor to 10, you need 500 concurrent executions available. Watch both the IteratorAge metric and your account's concurrent Lambda executions metric together. Now for the single most powerful heuristic in this entire course. The serverless rule, real-time requirements cannot be satisfied by buffered or scheduled components. Why? Because buffering, batching, and scheduled refreshes all add latency. Firehose buffers. S3 is object storage, not a stream. QuickSight refreshes on a schedule. None of these can deliver in milliseconds. And one nuance on Lambda, Lambda itself can absolutely be a real-time consumer on data streams. What's incompatible with real-time is Lambda batch processing with long batch windows or scheduled invocations. Asking for real-time from Firehose is like asking for a same-second response from a service whose entire job is to buffer first and deliver later. On exam day, if you see real-time in the question and Firehose S3 or a batching pattern in an answer choice, that answer is wrong. This rule alone will eliminate 2 or 3 distractors on most streaming questions. Let's drill the keyword triggers fast. Millisecond or sub-second latency, Kinesis data streams, least operational overhead delivering to S3, Firehose, multiple consumers needing dedicated throughput data streams with enhanced fanout. Convert JSON-to-Parquet with no separate ETL job, Firehose format conversion with a glue schema. Stateful, windowing, or exactly once, managed service for Apache Flink. Replay data from 30 days ago, data streams with extended retention. Kafka API compatibility or migrating Kafka producers, Amazon MSK memorize this table. It's the decoder ring for every streaming question on the exam. Quick gotcha round because the exam loves these. Firehose's minimum buffer is 60 seconds, and even with zero buffering, it's a few seconds at best, still not real time by exam definitions. When you enable format conversion, the buffer minimum jumps to 64 megabytes, and smaller values are flat out rejected. Schema mismatches in format conversion don't fail gracefully. Firehose writes the bad records to an S3 error prefix, which can stall delivery until you resolve the schema drift. Kinesis delivery is at least once, not exactly once, so duplicates are possible and your consumer code needs to deduplicate using a unique record ID. And on MSK with IAM authentication, your Kafka CLS are completely ignored. You have to use IAM policies for authorization in that mode. Here's your streaming cheat sheet. Real-time in milliseconds is data streams. Near real-time at 60 to 900 seconds is Firehose. No exceptions. Enhanced fanout is data streams only, dedicated 2 megabytes per second per consumer, pushed at around 70 milliseconds. Firehose format conversion replaces an entire glue or EMR columnarization job. High IteratorAge is fixed by more shards, higher parallelization factor, or enhanced fanout, never by raising Lambda concurrency. Choose MSK only when Kafka compatibility is explicitly required, otherwise Kinesis. The serverless rule eliminates 2 or 3 wrong answers on every real-time question you see. Now let's lock this in with 5 practice questions. Alright, question 1. A fraud detection system must analyze credit card transactions and trigger alerts within 100 milliseconds of the swipe. Which architecture meets this requirement? Is it A, Kinesis data streams with a managed service for Apache Flink consumer using enhanced fanout? B, Kinesis data Firehose with zero buffering delivering to Lambda? C, Kinesis data Firehose delivering to S3 with an Athena trigger? Or D, Amazon MSK with Lambda batch processing every 60 seconds? Take a moment to think about it. The answer is A, the 100 millisecond requirement is real time, which immediately rules out anything with Firehose. Even zero buffering sits around 5 seconds. Data streams with enhanced fanout delivers in about 70 milliseconds, and Flink handles the stateful fraud detection. The serverless rule eliminates B and C, and option D's 60-second batch is obviously too slow. Question 2. A Lambda function processing a Kinesis data stream has a steadily rising IteratorAge metric. The stream has 4 shards and the function uses default settings. Which change will most directly reduce IteratorAge? Is it A, increase the Lambda function's reserved concurrency to 100? B, switch the Lambda function to provisioned concurrency? C, increase the parallelization factor on the event source mapping from 1 to 10? Or D, reduce the Lambda function's memory allocation to save cost? Take a moment. The answer is C, IteratorAge is a read throughput problem, not a concurrency problem. Raising the parallelization factor from 1 to 10 lets up to 10 concurrent Lambda invocations process each shard, multiplying read throughput. Options A and B are the classic exam traps. Reserved and provisioned concurrency don't add per shard read capacity. D would actually make things worse. Question 3. A retail company needs to ingest clickstream JSON into an S3 data lake as Parquet files, partitioned by date with the least operational overhead. Which solution fits? Is it A, Kinesis data streams with a custom KCL consumer running on EC2 that converts JSON to Parquet? B, Amazon MSK with a Spark streaming job on EMR writing Parquet to S3? C, Kinesis data streams feeding a glue streaming ETL job that writes Parquet? Or D, Kinesis data Firehose with format conversion enabled using a glue data catalog schema? Think it through. The answer is D, the phrase least operational overhead points straight at Firehose with format conversion. It deserializes JSON, looks up the schema from the glue data catalog, and serializes to Parquet, all natively inside Firehose. The other options all require custom consumers, EMR clusters, or separate glue jobs which add operational burden. Question 4. A company is migrating an on-premises Apache Kafka workload to AWS. The existing producers and consumers use Kafka client libraries with topic-level ACLS and SASLSCRAM authentication. Which service should they use? Is it A, Kinesis data streams, rewriting the producers and consumers using the KPL and KCLB? Kinesis data Firehose with existing Kafka producers pointed directly at the delivery stream? C, Amazon MSK with SASLSCRAM authentication and Kafka CLs for topic authorization? Or D, Amazon MSK with IAM authentication and Kafka CLs for topic authorization? The answer is C, MSK is the right service for Kafka migration because clients work unchanged. The question specifies SASLSCRAM and topic CLS, so C matches exactly. Option D is the trap. When you use IAM authentication on MSK, Kafka CLS are completely ignored. You'd have to use IAM policies instead, which would defeat the goal of preserving the existing ACL configuration. Last question. A retail company ingests clickstream events. The analytics team needs to query the data with at most a 5-minute delay, while a fraud team needs sub-second access to the same events. Which architecture serves both requirements? Is it A, Kinesis data streams with two consumers, enhanced fanout for fraud, and Firehose with format conversion to S3 for analytics? B, two separate Firehose delivery streams, one to S3 and one to Lambda? C, Kinesis data Firehose with format conversion to S3 plus Athena federated queries for fraud? Or D, Amazon MSK delivering to both S3 and Lambda using Kafka Connect? The answer is A. This is the classic combo pattern we covered. Data streams handles ingestion with multiple consumers. The fraud team registers for enhanced fanout and gets about 70 milliseconds latency. The analytics team gets a Firehose consumer that buffers, converts JSON to Parquet, and lands it in S3 for Athena. Each downstream consumer gets exactly the latency tier it needs. Option B fails the serverless rule for the fraud team, and option C tries to use Athena for sub-second queries, which it can't deliver. And that's a wrap on Amazon Kinesis, real-time versus near real-time streaming. If this helped you out, smash that like button and subscribe for more. See you in the next one.